Hello again and welcome back. We're now going to look at the second test in the test sequence, which is continuity of ring final circuits. Now, regulation 612.2.2 requires that a test shall be made to verify the continuity of each conductor, including the protective conductor of every ring final circuit. This is necessary to confirm that the line, neutral, and protective conductors of the ring final circuit are properly terminated at each socket outlet, and that each of the conductors of the ring final circuit is continuous and unbroken, and that there are no interconnections, which are sometimes known as bridges in the circuit. The test comprises of 3 specific steps and is carried out using a low resistance ohm meter or a multifunction test instrument on the continuity setting. And please note, if the 3 steps are carried out correctly, this will also prove the polarity at the socket outlets. Step 1. Disconnect the line, neutral and circuit protective conductors of the ring final circuit at the distribution board. Now, it may be advantageous at this stage to identify the incoming and outgoing conductors of the ring final circuit. This is very helpful when carrying out step 2 and 3 of verifying the ring final circuit. At the distribution board, measure the resistance between the line conductors. This is called R1. The neutral conductor, which is called Rn, and the CPCs, which is called R2. When measuring the resistance, the value obtained will be dependent on the length and cross-sectional area of the conductors of the circuit. And it should therefore be expected that if all conductors of the circuit are the same size, the value of resistance for R1, Rn and R2 will be the same. If higher values than expected are obtained, it may indicate there are some loose connections at socket outlets. And if lower values than expected are obtained, it may indicate there is an interconnection somewhere in the circuit. In a circuit where a cable type with reduced size of CPC is used, such as where a ring final circuit is wired using PVC flat twin and earth cable, the CPC resistance will be higher than the value of the resistance measured for the line and neutral of the circuit. The value measured will be in the ratio of the line and CPC conductor size. So for a 2.5 square mil with a 1.5 square mil CPC, the resistance of the CPC will be approximately 1.67 higher than that of the line conductor. The measured values of resistance between line to line, neutral to neutral and CPC to CPC should be recorded in the schedule of test results in the appropriate column for ring final circuit continuity in the respective R1, Rn and R2 columns. The inspector should also remember to compensate the measured value for the resistance of the test leads as demonstrated in the previous video. Step 2 is to verify that there are no interconnections made within the circuit. After completion of step 1, at the disconnected conductors located at the distribution board, connect the incoming line conductor to the outgoing neutral conductor and the outgoing line conductor to the incoming neutral conductor using a terminal strip connector. This creates a figure of 8 connection and allows us to measure continuity between line and neutral at each socket outlet. There are special plug-in test adapters that have been specifically designed for this purpose. The value obtained at each socket outlet should be approximately a quarter of the combined R1 and Rn value that has been measured in step 1, and be of a similar value at each socket outlet. However, socket outlets which have been connected as unfused spurs could show a higher resistance value. If, for some reason, an interconnection or bridge has been made in the ring final circuit, the resistance value measured will increase incrementally at each socket outlet after the point where the interconnection has been made, until the middle of the interconnected circuit is reached. It will then incrementally reduce in value at each socket outlet until we reach the socket outlet located just before the point where the interconnection has been made. And you should also note, if the outgoing and incoming conductors of the circuit have not been correctly identified at the beginning of step 2 when connecting the figure of 8, this error will be revealed from the first socket outlet in the circuit in a similar way with the increasing and the decreasing resistance value. Also, the value obtained in step 2 does not need to be recorded. However, it's often noted in the remarks section of the schedule of test results for the inspector's own information. Now, step 3 is to establish the effective R1 plus R2 of the ring final circuit and is similar to step 2. However, at the distribution board, you connect the incoming line conductor to the outgoing circuit protective conductor and the outgoing line conductor to the incoming circuit protective conductor. This again creates a figure of 8 connection, which allows a continuity measurement to be made between line conductor and circuit protective conductors at each of the socket outlets connected in the circuit. As per step 2, this can be measured using the special plug-in adapter that we mentioned before. The value obtained at each socket outlet should be of a similar value and should be approximately a quarter of the combined R1 and R2 value measured in step 1. Any reversal of line or neutral conductors at any of the socket outlets connected will also be revealed during this process and will show up as an open circuit test measurement at the relevant socket outlet where this has occurred. And note, where a defect or omission is discovered during the inspection or test process, the defect or omission shall be made good and the test repeated to obtain a satisfactory outcome before proceeding further. On completion of step 3, the value obtained should be recorded in the relevant column of the schedule of test results as the R1 plus R2 of the ring final circuit, which is the effective midpoint of the circuit. And finally, remember to reinstate the circuit on completion of the test. And that concludes this video on continuity of ring final circuits. Now you need to watch the next in the series on insulation resistance.